So, hello everyone, my name is Fabricio Sosa Castillo, and I am presenting the research style titled Noise Reduction using Polymer Composites, conducted by Fabricio Sosa Castillo, Ariel Eduardo Alarcón Fuentes, Leonel Toledo Sesma, Mónica Rosalía Jaime Fonseca, and Diana Palma Ramírez. So, first, noise pollution is a major environmental and health issue generated by vehicles that represents a growing problem. So, while modern cars already use soundproofing materials such as foams, mats, and panels, there is still room for improvement, especially in lightweight, sustainable, and multifunctional solutions. This study investigates the possibility of incorporating natural fibers into commercial automotive paint to improve its sound insulation properties. The dispersions of microcrystalline cellulose and nanocellulose C and NC extracted by chemical methods were prepared in 0.1, 1, 3, and 5%. The coatings were applied in aluminum substrates, and then the samples were characterized by Raman spectroscopy, X-ray diffraction, and light microscopy. Uh, Also, resistance to humidity and acoustic mitigation were evaluated. So, how we prepare this material? Uh, as I said before, we prepare for concentrations of C and NC 0.1%, 1%, 3%, and 5% by weight. Uh, the NC particles were extracted from commercial cellulose, sigma aldrich, through bleaching with sodium hydroxide and hydrogen peroxide during 4 hours, and hydrolyzed with 64% of sulfuric acid and dialyzed. The CNC NC particles were previously dispersed in acetone and added to the paint through ultrasonic process to reach homogenization. The obtained mixtures were applied on aluminum alloy plates with a film applicator using a thickness of 110 nanometers. A box was constructed with the aluminum plates and sealed with silicone. Two holes were left with 5.9 centimeters diameter at the ends. So, well, this is how we made our boxes to make the soundproof test. But before we take the paint with different concentrations of C and NC, and we made Raman, XRD, and humidity test. So in chemical structure, we Raman and XRD confirmed that adding the cellulose didn't alter the main chemical composition of acrylic paint. Titanium dioxide already present in the paint as a pigment and remain unchanged. We can see that, that adding, in this case, cellulose and nanocellulose, we don't see any change in between the reference paint that is here. So we can confirm that it's still the same. We cannot see any changes with the adding of the both cellulose. In change, the water absorption, we can see that the adding adding more percentage of cellulose and nanocellulose grows the absorption of humidity of this paint. In this case, the most low absorption we can see is the cellulose 1%, but the other samples is still the same absorption grows. And in the soundproof test, we can see that C in 5% has the lowest acoustic pressure. That it's it seems like the acoustic pressure go down. It's down. So in this case, the in 5%, it's our best acoustic per soundproof performance. Is our best soundproof performance. So, in conclusion, cellulose was successfully extracted but without altering its functional groups. The paint was identified as acrylic with titanium dioxide, and no cellulose signals were detected due to equipment limitations. Both cellulose and nanocellulose show mixed polymorph, the type 1 and type 2, and their addition did not affect the paint crystalline structure. C caused more agglomeration than NC, and moisture absorption increased slightly with both. Notably, paint with 5% of C showed the best acoustic absorption performance. So that's all. Thank you for your attention.